Welcome, dear viewers, to an inspiring journey through the annals of scientific history. Today, we invite you to explore the extraordinary life of Marie Curie, a genius who overcame every obstacle to shape the future of medicine and physics. Join us as we delve into the story of her courage, talent, and everlasting legacy, a journey that will keep you captivated from start to finish. Marie Curie stands as one of the most iconic figures in the global scientific community. Her remarkable journey began with a defining moment at the prestigious Solvay Conference in Brussels in 1927, where she was the sole woman among 29 leading physicists. With her unparalleled achievements, she not only became the first woman to win a Nobel Prize, but also the first person to receive this honor twice. A unique record achieved through her mastery of both physics, 1903, and chemistry, 1911. The world recognizes her for pioneering research on radioactivity, a discovery that saved millions of lives during World War I through medical applications. Yet, the poignant irony lies in the fact that this very work silently eroded her health, leading to her tragic death in 1934. Her remains now rest in the Pantheon in Paris. Since 1995, encased in a specially designed lead-lined coffin to contain the radiation still emanating from her body, even her documents, notebooks, and papers remain highly radioactive, requiring researchers to wear protective gear and sign liability waivers before a vivid testament to the immense sacrifice of this extraordinary genius. Marie Curie, originally named Maria Skłodowska, was born on November 7, 1867, in Warsaw, Poland, during a time when the nation was under the control of the Russian Empire. As the youngest child in a family steeped in educational traditions, she grew up under the guidance of her parents, her mother, Bronisława, who served as the headmistress of a prestigious boarding school for girls, and her father, Władysław, a dedicated teacher of physics and mathematics who took great pride in Poland's cultural heritage. However, his fervent patriotism drew the ire of Russian authorities, resulting in demotions to lower-paying positions and the family's complete loss of savings due to a failed investment. To support their 5 children, they were forced to take in student boarders. This decision proved fatal. Maria's eldest sister, Zofia, succumbed to typhus, contracted from a lodger. And just a few years later, when Maria was 10, her mother passed away from tuberculosis. These devastating losses led Maria to abandon the Catholic faith of her mother and adopt an agnostic worldview. Despite excelling as a top student in her class, she faced a significant barrier. Her gender barred her from attending formal universities under Russian rule. Undeterred, she joined the Floating University, an underground educational institution in Warsaw, where classes were held secretly at various locations to evade the watchful eye of Tsarist authorities. From the age of 17, Maria worked as a governess to earn a living while continuing her studies in private. During this period, she fell in love with Kazimierz Kurawski, the son of her employers and a future mathematician, but his family rejected the relationship due to her lack of wealth. After years of saving, at 24, she finally amassed enough resources to leave Poland, arriving in Paris to enroll at the renowned Sorbonne University. There, despite living in poverty, relying solely on bread and tea, she persevered through hardships and times, fainting from hunger to earn her bachelor's degrees in physics and later mathematics, laying the groundwork for her illustrious career in Paris. Fate brought Marie the name she adopted upon arriving in France into the life of Pierre Curie, a distinguished physicist 8 years her senior, in 1893. Initially, Marie harbored plans to return to Poland to contribute to her homeland. But a visit to Warsaw during the summer break of 1894 ended in disappointment when the War University of Krakow denied her a professorship solely because of her gender. Pierre, recognizing her immense potential, persuaded her to stay in Paris and pursue a doctoral degree. He also committed to earning his own doctorate, pioneering research in magnetism. The couple married in 1895 at the Town Hall in Sceaux, a suburb of Paris, forging an inseparable partnership in both life and science. In 1896, a discovery by physicist Henri Becquerel about the emission of X-ray-like radiation from uranium sparked Marie's curiosity. Using an electrometer invented by Pierre and his brother, she began her investigations and concluded that radioactivity was an intrinsic property of the uranium element, unaffected by chemical or physical changes. This insight led her to analyze pitchblende, a highly radioactive mineral. She observed that its radioactivity far exceeded what uranium alone could produce, suggesting the presence of other elements. Together with Pierre, they embarked on a grueling task, grinding tons of pitchblende in a leaky, makeshift shed near Pierre's laboratory due to the lack of a dedicated workspace. In 1898, they announced the discovery of two new elements, polonium, named after Marie's native Poland, and radium, derived from the Latin word for ray, exhibiting radioactivity 900 times stronger than polonium. They also coined the term radioactivity to describe this phenomenon. After 4 years of relentless effort, by 1902, they successfully refined 0.1 grams of pure radium chloride from tons of ore, a remarkable feat for that era. In 1903, the groundbreaking work of Marie Curie and Henry Becquerel was honored with the Nobel Prize in Physics for their contributions to radioactivity. However, the Nobel Committee initially nominated only Curie and Becquerel, overlooking Marie's pivotal role, a clear reflection of the gender bias prevalent at the time. Thanks to Curie's staunch advocacy, Marie was included, making her the first woman to receive a Nobel Prize. Too engrossed in their research to attend the ceremony in Stockholm, they sent their regrets, unaware that Curie's emerging health issues were linked to radiation exposure. Tragedy struck in 1906 when Curie was fatally struck by a horse-drawn carriage while crossing Rue Dauphine in the rain. Devastated, Marie resolved to carry on his legacy, stepping into his academic post at the Sorbonne and becoming the first female professor there, drawing hundreds to her inaugural lecture. In 1911, she earned her second Nobel Prize, this time in chemistry, for the discovery of polonium and radium, as well as the isolation and analysis of radium, cementing her status as the only person in history to win Nobel Prizes in two different fields. Yet, this peak was marred by controversy. The French press sensationalized her affair with Paul Langevin, a former student and estranged physician, branding her a hoax. The public backlash plunged her into depression, but a supportive letter from Albert Einstein, a fellow attendee at Salve, bolstered her resolve, enabling her to travel to Stockholm and accept her second Nobel Prize. When World War I erupted, Marie refused to remain a bystander, driven by a humanitarian spirit. She developed the Petites Curies mobile X-ray units to assist battlefield surgeons in locating shrapnel and bullets in wounded soldiers. She personally drove these units, training 150 women to operate them, alongside her daughter Irene, while overseeing the operations of 200 field radiology rooms. Her efforts are estimated to have saved approximately 1 million lives. During the conflict, she safeguarded her precious radium by relocating it to a bank vault in Bordeaux, the temporary French capital, and attempted to sell her to Nobel medals to fund the war effort, though the National Bank declined. Instead, she invested her prize money in war bonds. Aware of the radiation hazards, she lacked the time to implement safety improvements. The toll became evident in 1934, when, at age 66, she passed away in a sanatorium in Passy, eastern France, due to a plastic anemia blood disorder likely caused by prolonged radiation exposure. The French government offered no official recognition, while U.S. President Warren Harding invited her to the White House in 1921, presenting her with 1 gram of radium for further research. Embarrassed by their lack of acknowledgement, the French government proposed the Legion of Honor, which she declined. Her daughter Irene, along with her husband Frederick Joliot, later received the Nobel Prize in Chemistry in 1935 for creating artificial radioactive elements, continuing her mother's legacy after laying the foundational stones for scientific achievement. Marie Curie went on to lead the Radium Institute in Paris, later renamed the Curie Institute, a pioneering research center that remains influential to this day. At the same time, she established a similar branch in Warsaw, turning it into a beacon of Polish science. These research institutes were not merely the product of her personal efforts, but also vivid proof of the far-sighted vision of an exceptional scientist. Marie Curie's legacy extends far beyond her personal achievements, forming a solid foundation for multiple scientific fields. Her research on radioactivity opened doors to the development of modern physics, analytical chemistry, and particularly oncology, as radiation therapy began to be widely applied. Her work also helped advance technology, medicine, and nuclear physics, paving the way for major breakthroughs in science throughout the 20th and 21st centuries. However, Marie Curie's extraordinary talent and tireless work ethic came at an unforeseen cost. Her relentless dedication and prolonged exposure to radioactive substances such as radium and polonium quietly claimed her life in 1934. Though she paid the ultimate price with her own life, she left behind an immortal legacy, inspiring generations of scientists with her resilience and passion for discovery. Marie Curie was not only a brilliant scientist but also a symbol of courage and sacrifice, forever shining in the history of humankind.